Okay, let's start the homework 5, the compound stoichiometry. I'm going to do some problems. And let's start with the number 1. First, decide whether each of the following formulas represent an ionic or molecular substance. If molecular, then decide if the formula is molecular empirical and or the actual or true molecular formula. I just cut and paste some of them, not to do all, but you can do the rest of them, me working on this. So let's start with B, letter B. Is this a molecular empirical? How do you recognize a molecular ionic? It's a molecular. How do you recognize it? Because it doesn't have the metal the compound doesn't have a metal on the left. The metal would always be on the left. So you see, well, at least at this level. So you would see, and it's always the least electronegative element on the left. On the left. So you're looking at this, and you phosphorus is the non-metal with a non-metal. By the way, let me name it so we practice the naming for this exam, and it's gonna be tetraphosphoro pentaoxide. Tetra tetraphosphoro phosphorose tetraphosphorose. Oh no, yes, phosphorus pentaoxide. So let's start. Is this a molecular? Yes. Now let's look at this if it's empirical or not. If you can divide by a whole number and you still get a whole number ratio, that is a molecular. In this case, you have a P4O10. And if you divide it by 2, it's going to be P2O5. So it is molecular. On the letter C, right? On the letter C, we got triphosphorus, pentaoxide. Remember, it's molecular, okay? And it's one word here. So, what do we have? Is it empirical molecular? We can't divide it. We're not going to get a smaller ratio than this one, 2 to 5. It's not going to be, you can find a common denominator here. So this is empirical, okay? And this is, in fact, if you look at this is the empirical for this one, for the molecular, okay? Empirical. And this is going to be for the molecular. Do you see? This is empirical. Now let's get on G. Is this molecular or ionic? It's molecular. I2 is a molecular formula. But this would be the empirical. Why? Even though you can divide it by 2, is the iodine, remember, are those the molecules that exist as the atomic molecules? Now let's get in H2O2. And it's going to be K. H2O2. And it's going to be dihydrogen dioxide. And it's hydrogen peroxide. And it's peroxide, we'll see it because it has the O2 here. So it is empirical or molecular. It is a molecular. So the empirical would be HO. Okay, it's a ratio 1 to 1. Magnesium phosphate. Is this ionic or molecular? Letter L. Magnesium sulfate. First of all, phosphate, not sulfate. First of all, it's an ionic. It's an ionic compound. Magnesium 3 phosphate. Polyatomic, ionic, um, and type 1. Magnesium is, the charge of magnesium is +2. so we don't have to give the charge. So it's magnesium phosphate. We name it. Okay, and it's ionic. Remember, we're going to say if it's empirical or not when it's molecular. Why? Because an ionic compound is always the minimum ratio because it's dependent on the charge. N2H4, is this empirical or molecular? We can divide it by 2. Okay, and if we divide this by 2, we're going to get the I, N2. Okay, we divide N2H4, this would be the empirical. So with H and I, with H, we have N2H4. This would be molecular because if you divide it with, by 2, we still get, or by any number you can divide it by 2, you still get a whole number ratio. Okay? So if you look at it, I would be the empirical because it's the empirical here. Empirical. Okay, let's go with problem number empirical. Let's go with problem 2. On problem 2, I'm going to put a pause here. So problem 2, right, it's just asking us for the molar mass, okay, of 1 mole in gram. Is the molar mass is the grams of an atom of a molecule in 1 mole. So let's calculate. I want to review it with you. And what do? Well, you multiply 12 for letter A, 12 by the atomic mass of carbon, 0.11 grams per mole. If you prefer to do 1, then on the bottom, however you decided, or just add them in. I mean, writing them down plus plus like I was writing in class. Or you can do it like that. Uh, 22 times 1.0079 grams per mole plus 11 multiplied by 15.9994 grams per mole. And that is going to give you, for each one, 12 multiplied by 12.011 gives me 144.132 grams per mole. On the second one, 22 multiplied by 1.0079 is equal to 22.17 38 grams per mole. And finally, 11 times 15.9994 is equal to 175. 0.9934 grams per mole. Then we add them all together. 144.132. I don't know if it's right. You can double check by your own. 342. 42.2992. Now, you have three decimal. The right way is 342.123. 299 grams per mole. That's the right amount. But they're asking only for 5 cifics. So you would do 342 point. If you round this, you have to drop this one. So it's going to be 30. But you have to keep the 0 because they're asking for 5 cifics. Now the next one. Let me do real quick magnesium. Magnesium, I don't know it by memory, the weight of magnesium. For the B would be magnesium phosphate. By the way, I think I made a mistake on question number 1. When I said magnesium phosphate, I missed here the 2. Now I'm looking that the weight of here is a 2. Yeah, because the weight of the charge of magnesium is 2 and the phosphate is -3. You cross multiply. You see it is magnesium PO4 2. So here to calculate that is 3 times the magnesium. So I'm going to put a pause while I look for my periodic table. Okay, it's 24.305 magnesium. Grams per mole, that's magnesium. And then the phosphorus, you would have 1 atom here multiplied by 2. You have 2 phosphorus. You see here you have 1 by 2 because you have 2 PO4 in total. So multiply by the molar atomic weight of phosphorus, which is 30.973676. 34.97. Let me see it again because 30.97376. 30 point 30.97376 grams per mole. And then we have oxygen, which is going to be 4 by 2, right? 8 by the atomic weight of oxygen, 15.9994 grams per mole. So let me make the calculation real quick. If I made a mistake, you do it yourself too. So 72.19 72.9 72.915 grams per mole. Here you got 2 by 330 by 30. I know what I because I made a mistake here. I wrote three twice. 30.97376. So it's gonna be twice because we have to phosphoro 30.97376 is gonna be equal to 61.94752 grams per mole. And here 4 times 2, 8 by 15.9994 equals 127.9952 grams per mole. So you got here, okay, let's add them all together, okay, and it's gonna be plus 72.915 plus 61.947 is gonna be 262.85772 grams per mole. Of course, if you take it like that, you take it with three decimals. This is the right way we were learning. So you have to drop this 72, which is going to be 58 grams per mole. But they're asking for a certain amount of sig figs. Let's see how many do we got. 6. Let's look at this. 6, the same value. Okay, the same number of sig figs. So it's 6 and counting the decimal the same thing. Now let's go to the next problem, right? And you got calculate the mass in grams. That's why I practice the molar mass to make sure that you all understand it. Calculate the molar mass, right? Calculate the mass in grams of the following compound. There's several of them, but I just chose one. This is very easy because it's the same thing you have to do on all of them. The only difference is that you need to find the molar mass of the whole compound. So calculate the mass. They're asking for the mass in grams for the following compound. And if you look at their flow chart, you're going to get grams of molecules here, okay? And this, right, goes to moles of molecule. And that's what they give in moles of K2CrO4, which is a compound, which is a molecule. Moles of molecules. So you multiply by the molar mass in grams per mole. And remember, if you want to go up, you divide by molar mass. The opposite. It's the opposite. And this is, hold on. And this is going up, you multiply by the molar mass in grams per moles. If you're going down, you divide by the molar mass. Okay? So in grams per mole. So they're asking for the mass, and you got the moles, so you can go up, you multiply by the molar mass. So the mass in grams would be 48.1 moles multiply by the molar mass of K2CrO4. I always advise my students when they're doing stoichiometry problems, start with the, if you're doing grams, start with the molar mass. What would be the molar mass here? It would be twice the molar mass of K2CrO4 SO4 would be twice potassium, which is 40 something. Potassium is 39.0983 by 39.0983 grams per mole plus 1, I don't remember the chrome. Chrome would be 51.996, 51.996 grams per moles plus 4 times 15.99994 grams per mole. Again, again, again. So I'm going to give you the molar mass directly because I have the answers. And it's going to be, this is number 2 or 3. So it's going to be 194.2. That's the molar mass. The molar mass of K2CrO4 is 194.2 grams per mole. You do the same thing as we did in the last problem. You keep on calculating that. So now what do you have to do? You go ahead and multiply 48.1 moles, and it's going to be the mass of the compound would be 48.1, right? Was it point 1? Yeah. 48.11 moles. You multiply by 194.2 grams per mole. 0.2 grams per moles. And this, right? You cancel out the moles, and the mass is gonna give you 934 by 10 to the third. Remember, always you need to 9.34 times 10 to the third times 10 to the third grams of potassium dichromate, chromate. So it's gonna be by 10 to the again third, 10 to the third grams of K2CrO4. Now that's it. That's it. And every time you have moles, remember that. That's why I give the flow chart from mass, from grams to moles. You divide by molar mass in grams per mole. From moles to mass, you multiply by molar mass. As you have the, if you know the compound what it is, you can always do that. If you have grams, you're always gonna have. It's like doing with the problem with density. When you got density, you find out the volume. If you have volume, you can find out the mass always. Okay, so unless we're gonna get in those tough problems, unless we don't know the compound. So let's go now to find out the moles, how I said. Remember the flow chart. If you look at your flow chart, then we have to divide 1,535 grams divided by the molar mass of aluminum sulfate. Aluminum sulfate is the name, and it's a type 1. See that I'm naming everything now before I did it, and now I'm naming it so that way you should know it by now, but you review it. Okay, so we got here that is gonna be, what is the molar mass of aluminum 2SO4? If you want, I can do it, and it's twice aluminum, which aluminum is 26 something, 2698, 154, 2698, 154 grams per mole, plus 3 by 32 the sulfur, 3207 grams per mole, plus 12, because we got 4 oxygen multiplied by 3, 12 by 15.9994 grams per mole. So this is gonna be 96 2 by 26.9154 equals 5353.8308 grams per mole. And then 96.21 grams per mole. And finally here 12 by 15.9994 equals I 191.9928 grams per mole. So this is gonna give you 191 plus 96.21 plus 53.8308 gives you 342.0336 grams per mole. So see the decimals, if you would take it to the right number of sig figs now, you would only have two decimal, 342, but we usually take it to the number of sig figs when we finish the problem. So don't do it now because you're gonna need the decimals, and at the end, unless it's the answer that I'm looking for, that I'm asking for. So here would be always when you finish answering a question, a letter, what the part of the problem that I'm asking. For example, if I would ask you for the molar mass, you have to take it to the right amount of sig figs. And we have 3. So it's 153 grams divided by the molar mass we just found. That it was 342.0336. 342.0336 grams per mole. And this is gonna give us, I'm gonna do it on bottom, okay? And it's gonna give us 153 divided by 342.0336 gives you 0.0 0.006535948 mouse. Now listen to me in a second. We need three sig figs, so we have to round it. And this is what the first part of this course is so important, the rounding. 1, 2, 3 sig figs, okay? 0.0065. Now we have to round it. What do we have to drop all this? Is this higher than 5,000? Because what you see is this 5948. Is it higher than, greater than 5123? Yes, it is. So it's gonna be, you round it up. So it's gonna be 4 moles. And this is 3 figs. You see how important it is to be able to do this. Okay, and that's our answer. Let me see, how many problems do we have? Okay, I'm gonna stop it now, start posting this video, and then I'll keep on going. But we don't have too much. I have like a little bit less than a half. But we have already 31. It's gonna be too long to post it on Angel. It takes too long. So upload it on Angel. So what I'm gonna do is start with this one.